Okay, for activity 8, we're only just going to do a small section of it and then move on to activity 9. I'm just trying to cherry pick what we go over as the semester is coming to an end, and not waste our time doing stuff that isn't really that relevant to the goals of Algebra 2. So we're on page 122 in lesson 8-1. We're going to talk about imaginary numbers, and I mentioned these in class. And I also mentioned it on the getting ready notes that we did in the Unit 2 intro. So basically, imaginary numbers came from this problem. And you can read this right here. It kind of talks about it some more. But, you know, if you have x squared plus 1 equals 0. First of all, this isn't factorable. And the question came up because let's just use algebra to solve this. So let's say we're trying to isolate the x. So we subtract 1, and we get x squared equals negative 1. And then to cancel out the square, we can take the square root. Square rooting is the opposite of squaring something. And we end up with this situation here. We end up with the plus or minus square root of negative 1. And mathematicians were really confused by this. How is it possible to take the square root of a negative number? Because if you think about it, when you square something, you're multiplying it times itself. And if we did negative 1 times negative 1, that would give us positive 1. And 1 times 1 is still positive 1. So it doesn't exist. The square root of negative 1 doesn't exist. So they came up with this idea, like, well, let's treat this number like we do pi. Let's give it a symbol. So anywhere you see I write it cursive, so it doesn't look like anything else. We're going to say we're just going to call this the square root of negative 1. And so basically, x here is going to equal plus or minus I. The square root of negative 1 is I, always. Okay? So anytime you see that, it's an understood square root of negative 1. And so you can add this to your vocabulary sheet, or Chem charts, if you're keeping track of that and using it to study. An imaginary number is any number of the form bi, where b is a real number and I is the square root of negative 1. So for example, if I have 5i, that can be rewritten as 5 times the square root of negative 1. Or if you have something like I square root of 3. Okay, this is I times the square root of 3. This would be the same thing as square root of negative 1 times the square root of 3, which would give you square root of negative 3. And, you know, this is bad form to leave it like this. This is technically, when it's written with I, that's considered the simplified form. It is considered bad form to leave the negative in the radical. So for example, if you were to start with the square root of negative 16, we can rewrite the square root of negative 16 as negative 1 times 16. And we can split that up some more as negative 1, square root of negative 1 times the square root of 16. And we can change the square root of negative 1 to I. And then the square root of negative 16 is 4. And so it's common practice to write the real number first and the I second. So the square root of negative 16 is 4i. So ask yourself this, what's the square root of negative 25 then? Well, we know the square root of 25 is 5, and since it's a negative 25, then our answer is 5i. So anytime you have a negative in the radical, that's when we're going to be dealing with imaginary numbers. Okay, so we're going to do some more examples here. So it says write the numbers square root of negative 16 and square root of negative 19 in terms of I. And you see right here, they immediately just pull the negative out. So technically you could just write this as a square root of negative 1 times the square root of 17. And they just change the square root of negative 1 to I. And since the 17 is prime, So in the warm-up, remember we broke numbers down into primes. 17 is just 1 times 17. So this is, by definition, a prime number. So it's going to stay in the radical. And good form for radicals, if you still have a radical in an answer, is to put the I in the front. It's less confusing, and it talks about it over here. Write I squared root of 17 instead of square root of 17I. It can be confusing. So it might look like, if you put the I behind it, it might look like you're trying to include the I in the radical, but when really it should be outside the radical. Okay, and then square root of -9. Again, you can break that up as square root of -1 times the square root of 9. Change the square root of -1 to I, and then change the square root of 9 to 3. And so we end up with 3I as our answer. Okay, here's some more examples. I actually just answered this one. We can rewrite as -1 square root of -1 times the square root of 25. So that's going to become, the -1 would become I, and the square root of 25 is 5. On B, we have the square root of -1 times the square root of 7. This will become I. And the 7's still in the house, so we'll put the I in front of it. 7 is prime, just like 17. It's only 1 times 7, so we can't do anything with it. Leave it in the house. And then on C, we can rewrite this as the square root of -1 times the square root of 12. Now this is where the Khan Academy videos that just assigned you are going to come in. You have to break down this 12, okay? And we're looking for perfect squares. So we have two 2's here. So the square root of -1 will become I. Since you have two 2's, that's a perfect square. So we'll take a 2 out, and the lonely 3 will stay in. So our answer is 2I radical 3. So basically, anything that's a pair, it's basically you're saying the square root of 4. The square root of 4 is 2. So we took the 2 out, and the 3 stayed in. And then on example D, again, that's -150. So that's the square root of -1 times the square root of 150. And we can change the square root of -1 to I. And now we need to break down the 150. So that's going to be 2 and 75, 3 and 25. And then 25 is a perfect square. So for this problem, our pair, we have a pair of 5's. The square root of 25 is 5. And then we're left with a 2 and a 3. And we can multiply those back together. Basically, you have 2 times 3 in here. So our final answer is 5I radical 6. So the number that's left inside should not have any perfect square factors, basically. Okay, and then you are going to submit 7, 8, and 9, A, B, C, and D. And that's all we're going to do for this lesson.